directions for this example are to simplify, and we're trying to simplify a log expression. So we would maybe need to use some properties of logs in order for us to do that. The fourth property down here does say if you have your base of your log and the base of your exponent the same, the answer is just the exponent. We do have a log base 3 here, and I do have 9 to the 5th power here, but the 9 and the 3, they don't match, so I can't use that property the way that it is right now. But if I can take the 9 and I can write it as 3 to a power, then the base would be 3 on both, and we can do that. So I'm going to rewrite this as log base 3. What we had was 9 to the 5th power. What I want to do is I want to take this 9 that's here and I want to write it as 3 to a power so it matches this one, and 9 is 3 squared. We do have a property of exponents that says if you have a power raised to another power, you multiply those exponents. So I can rewrite this as log base 3 of 3 to the 10th power. 2 times 5 would give me that 10th power. And now I have log base 3 of 3 to the 10th. The base of the log and the base of the exponent are both 3, so I can apply this property here, and the answer is just our exponent. For letter B, we'll do the same thing. We have log of 1,000 raised to the 4th power. Remember that if there is no base written with the log, that really is log base 10. They just don't write it in, usually. If it is log base 10, they just write it as log. So like we did in the last problem, what I would like to do is I would like to take the base of the exponent here and write it as 10 to a power so it matches this base of our log. And 1,000 is 10 to the 3rd. So I can write this as log base 10 of, still something to the 4th power, but I want to write 1,000 as 10 to a power, so it matches this 10. And 1,000 is 10 to the 3rd. And again, properties of exponents, if you have a power raised to a power, we can multiply those exponents. And 3 times 4 is 12. And now I have log base 10 of 10 to a power, which is this 4th property here again. We have a log of our base and the base of our exponent. Those two bases are the same. In this case, they're both 10. So the log and those two bases cancel out, and we just get an answer that is equal to our exponent. This one looks a little bit different. This time we have an exponent with a log in it. We have 5 raised to a power. That power is log base 5 of 7. And if you look at this last property of logarithms, that's the pattern we have. This property says if you have a value that is raised to a log power, and your value and the base of the log are the same. So again, the base of the exponent and the base of the log are the same. They all basically cancel out with the log, and we just get x for an answer. So here we have a 5. The exponent is log base 5 of a value. Because the base of our exponent is 5 and the base of our log is 5, all of that with the log will cancel out, and we will just get a final answer of 7.